Time has always been the one thing we cannot escape. We feel it slipping through our fingers every second. A relentless river flowing in only one direction, from the past through the present and into the future. But what if that river has eddies and whirlpools? What if we could build a vessel to sail against the current or leap ahead to the mouth of the stream? The idea of time travel has been a cornerstone of our myths and movies for over a century, from H.G. Wells' Victorian contraption to the glowing DeLorean of the 1980s. But as we peel back the layers of modern physics, we find that time travel isn't just a fantasy. In fact, according to the laws of the universe, it's not only possible, it's already happening. Today, we ask the ultimate question. Is time travel fact, fiction, or a future possibility? To understand how we might move through time, we first have to understand what time actually is. For centuries, we thought of time as a universal clock, ticking away at the same rate for everyone, everywhere. But in 1905, Albert Einstein changed everything. He realized that time is relative. It is linked to space, forming a four-dimensional fabric called space-time. And most importantly, time is flexible. It can stretch, it can shrink, and it can warp. This discovery opened the door to the first scientifically grounded form of time travel into the future. Traveling to the future isn't just a possibility, it is a proven physical reality. This happens through a phenomenon called time dilation. There are two ways to achieve this. The first is through speed. According to Einstein's special relativity, the faster you move through space, the slower you move through time relative to someone standing still. This has been tested and verified with atomic clocks on high-speed jets and satellites. If you were to board a rocket that could travel at 99% the speed of light and fly for what felt like 1 year to you when you returned to Earth, decades would have passed. You would have effectively leaped into the future of humanity. The second way to travel to the future is through gravity. General relativity tells us that massive objects like stars or black holes warp the fabric of space-time. The stronger the gravity, the slower time ticks. This is why clocks on the surface of the Earth tick slightly slower than clocks in deep space. If you were to spend a few hours orbiting near the event horizon of a supermassive black hole, where gravity is extreme, and then return home, you might find that hundreds of years had passed on Earth. You wouldn't have aged, but the world you left behind would be ancient history. In a very real sense, the astronauts currently aboard the International Space Station are time travelers because they move at high speeds and are further from Earth's gravity. They return to Earth a few milliseconds younger than they would have been otherwise. But while the future is open for business, the past is where things get complicated. Traveling backward in time is the holy grail of science fiction, but it presents a massive headache for physicists. To go back in time, we would need to find a way to curve space-time so severely that it loops back on itself, creating what scientists call a closed time-like curve. It's like a highway that circles back to the entrance ramp you just left. One theoretical way to create this loop is through a wormhole, a shortcut through space and time. Imagine space-time as a sheet of paper. If you want to get from one side to the other, you have to travel across the whole surface. But if you fold the paper and poke a hole through it, you can move between the 2 points almost instantly. If one end of this wormhole were accelerated to near light speed and then brought back, the time difference between the two ends could allow you to step in one side and emerge in the past on the other. However, there's a catch, or rather several catches. First, we have never actually seen a wormhole. They are permitted by the math of general relativity, but they might be inherently unstable. Physics suggests that the moment you try to enter one, it would collapse. To keep a wormhole open, we would need exotic matter with negative energy density, something we aren't even sure exists. Second, even if we could build one, many physicists, including the late Stephen Hawking, suggested a chronology protection conjecture. This theory implies that the laws of physics might conspire to prevent time loops from ever forming, perhaps through a massive buildup of energy that would destroy the time machine the moment it was switched on. Even if the physics allowed us to go back, we would run headfirst into the grandfather paradox. It's the classic logic puzzle. If you travel back in time and prevent your grandfather from meeting your grandmother, you would never be born. But if you were never born, you could never travel back in time to stop them. This creates a logical loop that breaks the law of causality, the idea that cause must always come before effect. To solve this, some scientists look toward the many worlds interpretation of quantum mechanics. This theory suggests that every time a decision is made or an event happens, the universe splits into multiple parallel realities. If you travel back and change the past, you aren't changing your past, but creating a new branching timeline. In this new universe, you were never born, but in the original universe you came from, everything remains the same. You haven't erased yourself. You've just moved to a different branch of the cosmic tree. Another potential solution is the Novikov self-consistency principle. This idea suggests that if you go back in time, you are physically incapable of doing anything that would change the present you came from. If you tried to pull a trigger, the gun would jam. If you tried to move a chair, it would end up being exactly where it was always supposed to be. In this view, the past is set in stone, and your presence there was always part of history. You aren't changing the past. You are fulfilling it. Despite these paradoxes, the search for a way to skip through time continues in the most extreme corners of physics. Some theorists have proposed the Temporal cylinder, a massive, infinitely long cylinder spinning at near-light speed that would drag space-time around it into a loop. Others look at cosmic strings, infinitely thin, incredibly dense leftovers from the Big Bang that could warp space-time enough to allow for time travel if two of them were to pass each other in just the right way. So, where does that leave us? As of today, time travel to the future is a fact of physics. We just need better technology to make the leap significant. But time travel to the past remains firmly in the realm of maybe. It sits at the edge of our understanding, at the point where Einstein's gravity meets the strange world of quantum mechanics. Until we have a theory of everything that unites these two fields, we won't know for sure if the door to the past is locked or just very, very hard to open. But even if we never build a physical time machine, we already have one. Light. When you look at the stars, you are looking into the past. The light from the sun takes 8 minutes to reach us. We see it as it was 8 minutes ago. The light from the nearest star, Proxima Centauri, takes 4 years. And when the James Webb Space Telescope looks at distant galaxies, it is seeing light that began its journey over 13 billion years ago. We are literally seeing the birth of the universe in real time. Astronomy is the ultimate form of time travel, allowing us to witness history without ever leaving our backyard. The dream of time travel reflects our deepest human desires, the wish to fix our mistakes, the longing to see loved ones again, and the insatiable curiosity to see how the human story ends. It is a reminder that we are creatures bound by a linear experience, yet gifted with minds that can imagine the infinite. Whether we ever step into a glowing portal or not, the fact that we can even ask these questions shows how far we've come. Time is the most precious resource we have. Physics tells us it is flexible, but our experience tells us it is fleeting. Perhaps the greatest lesson of time travel isn't about how to move through it, but how to value the moment we are in right now. Because even if you could travel to any point in history, the most important now is the one you are living. Thank you for joining us as we explored the boundaries of the possible. Time is a vast and mysterious landscape, and we've only just begun to map its terrain. If you enjoyed this journey through the dimensions, make sure to subscribe and hit the notification bell. We'll be continuing our voyage through the mysteries of the cosmos, from the smallest particles to the largest structures in existence. Until next time, make the most of your current coordinates in space-time. Keep looking toward the future, and never stop wondering about the secrets of the clock. Safe travels through the fourth dimension.